Today we're going to talk a bit about VLAN back segments with inside NSXT. How do VLAN back segments differentiate themselves from a traditional overlay segment? Well, NSXT VLAN back segments are exactly as they sound. They're not doing any overlay functionality at this point. They're simply setting traffic into the network tagged with the VLAN header that you requested. So this is great for existing network infrastructure, brownfield networks where you already have a large layer 3 footprint, things like DHCP services providing address allocation, existing routing platforms to provide routing and gateway capabilities. But if we combine the best of these things together, we get a great combination where we can leverage the existing underlying network infrastructure, but use the integrated and distributed security capabilities of NSXT. So let's have a look at how a VLAN back segment works in this case. If I look at my existing network infrastructure, I don't normally show the underlay network inside my lab topology because with NSXT we're typically overlaying traffic. But in this case we're going to be providing or handing off packets to the network, frames to the network, tagged with a VLAN header of our choice. We then expect the underlying network infrastructure to actually handle all layer 2 switching, all routing, and all ancillary services for us at that point. Inside my network I have an existing DHCP server. In this case we're going to be running our traffic on VLAN 123, and we'll be using this network. So any workloads attached to VLAN 123 that request an IP address will be provided by the existing DHCP server infrastructure that I have in place. Inside my network I have a couple of ESX hypervisors, of which there is an existing VDS configured as well. And the great thing about when we build out VLAN back segments is we get all inherent security capabilities provided by NSXT. So we can remove our reliance on existing chassis-based firewall solutions. We can remove our reliance on IDS and now IPS solutions from third parties as well, because we can support everything from a stateful layer 4 firewall right up to per packet inspection, IPS capabilities built directly into the kernel of the hypervisor. So in our case we're going to have a couple of workloads configured here as well. That'll all be attached to VLAN 123 on our VDS. And with NSXT we have an inline and distributed firewall capability that sits directly on the VNIC across our entire network infrastructure where NSXT is enabled. So with this solution, nothing can actually pass onto the physical network without passing through this security layer that is built into the kernel. So in this case, what we really have is a completely distributed firewall capability that spans across our entire virtualization fleet across the network that provides a fully distributed stateful security layer that is layer 4 up to layer 7, and new features can be added all the time because this is actually something built directly into the software layer of the kernel itself. So 2 hypervisors in this case, I could have 1,000 and I'll still have the same security capabilities built into the system, and not a centralized firewall is inside here with this solution. So to manage this, just like an overlay segment, I have NSXT Manager configured. This is really responsible for now communicating down to the networking layer, configuring security policies across the entire infrastructure, and obviously communicating with vCenter as our orchestration platform as well. So when we create a new VLAN back segment inside NSXT, this information is pushed up to vCenter, obviously, and when we deploy new workloads, new virtual machines, this information is shared down with NSXT as well. And we use that information to build highly dynamic security policies with dynamic address book objects, which are updated in real time as workloads are spun up and spun down. NSXT automatically learns the IP addresses of machines as well. Obviously, we're interfacing with the VNet, so we know what machines are, we know the makeup of those machines, we know their MAC addresses, we know their IP addresses, we know their names, and the other metadata we receive from vCenter, and all this is used to create highly dynamic security workflows. Let's have a look how this is configured inside NSX then. If we log into our NSX console, within the networking section under segments, to make a VLAN back segment, all I do is add a segment, we give it a name, VLAN 123 in this case, it can be whatever you want. We're not connecting it to a gateway, so we have no overlay requirements with a VLAN back segment, so simply configure the name of the segment, the VLAN, or the list of VLANs it needs to be using. We're not using an overlay transport zone, so we'll select a VLAN back transport zone. We're not configuring any IP addresses for layer 3 here because that's going to be handled by our existing underlying network infrastructure. We'll save this. That's all we have to do at this point. We'll jump over to vSphere, have a look at our distributed switch. As you can see, we now have this new NSX controlled VLAN backed port group which has been configured here. So you can see it's the type VLAN tag it's using, 123, and you can contrast this to an overlay segment which has no VLAN. We're simply using a VNI to provide isolation for our separate tenants and segments. Great thing about VDS on version 7 of ESXi or vSphere is we can support overlay segments, VLAN back segments, and also existing legacy port groups as well, all in the same switch, and all leveraging the same physical networking infrastructure within the hypervisor host. Let's attach some workloads to this as well. I've got 3 machines here I was going to use. So let's use VLAN 123 is what we configured. And we'll boot these up as well. And they should request an IP address from our DHCP server infrastructure here as well. Right, those 2 machines have come out. Let's just use this Kali Linux machine here as well, and we'll also put him on the same VLAN. Start him up too. Okay, this machine's got 192.168.123, 197. Web server 2. Let's have a look at you. Okay, 192.168.123, 200. Okay, so they've both been allocated IP addresses from the underlying and existing DHCP infrastructure. So this is not addresses that have been allocated through the distributed DHCP server that's built into our NSXT fabric. Let's see if we can communicate with each other here. 3.197. So we can actually forward between the two. So traffic from one virtual machine to the other is simply being passed out onto the existing network infrastructure and tagged with VLAN 123. But we are still passing through the firewall inside the product as well. Let's go and look at our security capabilities. We've got our other machine running, our Kali Linux machine as well, so it should be up and running. Cool, let's just log into him. We'll use this machine to actually send some malicious traffic towards one of our hosts as well. Okay, yep, okay, 198. 123.200. Okay, he can also ping that as well. So all these 3 machines are all on the same VLAN backed segment. Let's go and look at our security. So we still have the capability to enforce our security policy here as well. So just like with, so we have a default policy here that says allow, so we'll change that to drop. We should actually see a change in behavior there as well. So I can no longer ping because I've now changed the default any policy, which was at the bottom of my firewall policy, to now block traffic. So all I can do is actually send IPv6 neighbor discovery, and then DHCP server and client traffic is all that's allowed on this network right now. So if we want to allow ping to work again, as an example, let's the first thing we should do is create a dynamic address book entry here. So through the groups section, I've got a pre-existing one I've created as well. So let's look how this is built up. So the criteria to be a member of this group is to have a virtual machine name that contains the word web. And we have 2 machines that do that from knowledge. So if we look at the membership for this, we have web server 1 and web server 2, and the IP addresses that we've detected for this are 123.197 and 123.200. So the Kali Linux machine is not here because this machine name does not match web. So what's its machine name called? KALI, right? So we can add another group. I could obviously add this to the existing one as well, but let's say our criteria, virtual machine name contains, save that. So now we should have our Kali Linux machine has been automatically detected. We know its IP address, 198. So we can now use these dynamic address book entries for our security policy. Now if a new machine was to be spun up and created that actually matched that security that VM name, it would automatically be dropped into that group. So let's make a new firewall policy here. Demo 1. Let's add a new rule. So every policy needs rules. So we're going to allow anything to talk to these 2 machines. And we shall use it just for ICMP traffic, so our ping traffic. And let's also add an HTTP. Yes, for good measure. And we'll allow that traffic. So now we're actually saying sources to these machines, and now our ICMP packets are allowed through our firewall policy. So we're not changing the underlying physical network infrastructure in any way. We're simply just programming a stateful firewall policy directly into our hypervisor kernel and distributing that across all the hypervisors that exist in our network infrastructure. So what about turning on IPS? So to enable our IDS engine, it's very simple. We drop into settings here. It's currently not enabled at a cluster level. I've got a cluster that's called cluster, very creative. To turn on IDS, I simply tick the box. I can enable it across the cluster on individual hosts if I want to. So that has now been configured. We then have to make an IDS or an IPS policy. I've got one here that says my source is any, destinations web servers. Let's add in our Kali Linux box as well. And we're doing detect only. We could also do detect and prevent as well for a true IPS solution. So we're looking at all traffic between these source and destinations. We'll publish this, and we now have a fully distributed IDS capability, or IPS if I decided to prevent that traffic as well, that is enabled across every hypervisor. So we can actually send some traffic into the network as well. I probably already have some here. Okay. Oops, got to change the IP address. So let's change the target, the victim machine will be our 200 address, 192.168.3.200. So now we're actually sending in some attacks against the web server running on the 192.168.123.200 machine. So this is obviously we would expect our layer 7 IDS engine to start detecting this taking place. Right, so we're seeing them take place right now. So when they're pulsating like this means it's actually a live attack taking place right now. We've grouped these together. We're providing some level of severity, attack direction from client server. So we know it's actually going from the source IP address 198, which is our client machine, to our target victim 200. The important thing to note here is that these 2 machines are actually on the same subnet, on the same Vlan. Typically something difficult to prevent in a layer 2 environment. Obviously taking traffic back through a centralized IPS engine is possible, but obviously by distributing this requirement and this capability across our workloads, we're leveraging the raw horsepower provided by the compute platforms to do this for us. All right, and that's how simple it is to create a fully distributed firewall capability, IDS, IPS capabilities, and ever-increasing security capabilities built into the NSX product, using a traditional VLAN-backed model, and not changing our underlying physical networking infrastructure, keeping our existing layer 3 services in place across the network, and providing a path for you to actually move to a completely software-defined data center infrastructure that has no reliance on physical security appliances, whether they're firewalls, IPS engines, etc. Thanks for your time today. If you have any questions, please feel free to reach out to me. Always available. fpraus@vmware.com. Have a great weekend.